In this video, we demonstrate the IV Characterizer app, which, with KickStart version 2.6, has a new look and feel. For this demo, we will test an N-channel MOSFET using a Keithley series 2450 source measure unit to pulse the gate of a transistor, while one channel of a Keithley series 2612B source meter pulses the voltage across the drain. Let's have a look at the source measure units available in the Instruments tab. Because I already know that I want to use my 2450 as my gate biasing SMU, I can modify the name here to be more specific to its purpose in the test. Likewise, I can change the name of my 2612B. Let's drag our 2612 into the app staging window to get started. Here I select the IV Characterizer app, then click OK. Because I only plan to use a single channel of my 2612 in this test, I will disable channel 2. Let's now rename the first channel from SMU1 to drain so that we can ensure that the other controls in the app can help us better specify additional channel-dependent functionality. We set the type to pulse and can keep our voltage function and sweeping modes as they are. The final setting we will change in the source settings area is the stop voltage, updating it to 10. Note how the step size is automatically adjusted to 1 volt. This is in response to the source sweep points setting you see here in the Common Settings pane. We can leave the measure and instrument settings as they are for now. Even though we will be testing a 3-terminal device and could use the second channel of the 2612 as our gate stepper, we will instead bring in the 2450 as our second channel to help show off some of the other app setup features. Notice that above the Common Settings and New Waveform Viewer that the trigger type is indicating internal. This is because the app is presently only configured with just the one SMU. As we add instruments and channels, 2 other options will become available: software and TSP-Link. We will talk more about this in a minute. Because we want to use the 2450 to test the same device and ensure good trigger synchronization with our drain SMU, we click on the Add Instrument button. Select our gate 2450, then click on the OK button. Note the error message that is being presented. To allow the 2600 series SMUs to work in concert with the 2400 series graphical SMUs when pulse mode is involved, the TSP-Link connection must be made using the TSP-Link cable to connect the 2 instruments. For DC mode operation, the TSP-Link cable is optional, and when not connected, the trigger type will be indicated as software. When I revisit the trigger type indicator, then plug the TSP-Link cable into both my SMUs, I can see the type is updated to TSP-Link. Note here how the 2450 shows a Channel Settings Summary tab. Let's now change the channel name from SMU1 to Gate. Then click on the Settings Summary tab to bring the settings control for the channel into focus. We set the type to pulse, then change the source start to 3 volts. Notice how the step size is 200 millivolts, which is also in alignment with the source sweep points, and calculated with respect to the start and stop points. However, let's visit the Common Settings pane to define our stepper to be the gate channel. Notice how, once we define the stepper, that some additional controls become available. Let's leave these with the default settings, but do notice that the step size for our gate SMU has now been adjusted to 1 volt in response to the stepper points count of 3. Let's now modify some of our other common settings, changing the source sweep points to 21, the source to measure delay to 500 microseconds, the width to 2 milliseconds, and the off time to 200 milliseconds. Note above in the Waveform Viewer area that we get an approximate visualization of what is to be expected of each active SMU channel output. Let's run our app, then switch over to the graph view. We can hover above the legend to reveal its settings, then deselect the gate current measurements from appearing on the y-axis. We have the option to provide a title to our graph. We do so by hovering above the top center of the graph to expose the entry tool. Then type out IV Drain Characterization of N MOSFET. Finally, if we need to share our graph data with colleagues, We can right-click in the graph area to expose two options. Save As will allow us to save the graph data as a PNG file, and the Copy to Clipboard option will capture a snapshot of the viewing area for immediate sharing via email or pasting into a report. For more information about KickStart and all the apps available to automate your testing, please visit tech.com/Keithley-KickStart. Thanks for watching.